For decades, humanity has scanned the sky, not just for planets, not just for signals, but for the unexpected. For the rare moments when something in the universe doesn't quite fit, when reality drifts just slightly outside the boundaries of our understanding. And now, something like that may have appeared again. What began as a routine observation quickly turned into something far more intriguing. Astronomers tracking a newly discovered interstellar object, only the third of its kind ever confirmed, noticed subtle irregularities. Nothing dramatic at first. Just unusual. This object, informally compared to earlier visitors like Oumuamua and 2I, Borisov, was expected to behave in familiar ways. A faint glow. A predictable trajectory. Standard comet-like activity. But it didn't. Even in early observations, its brightness didn't match expectations. It appeared slightly more reflective than typical interstellar debris. Not impossibly bright, but enough to raise eyebrows. And that's when the James Webb Space Telescope was tasked with taking a closer look. Positioned far beyond Earth's interference, Webb is designed to detect faint infrared signatures, heat, dust, subtle emissions invisible to other telescopes. If anything unusual was happening, Webb would see it. And what it found didn't provide clear answers. It raised better questions. Instead of a dramatic glowing core or obvious comet tail, the data suggested something quieter, more subtle. A faint thermal signature. Not strong enough to indicate active outgassing. Not cold enough to be completely inert. Some scientists proposed a simple explanation. The object might be coated in unusual materials, perhaps rich in metals or carbon compounds, affecting how it absorbs and reflects sunlight. Others suggested its shape could be highly irregular, causing unusual brightness patterns as it rotates. This wouldn't be unprecedented. When Oumuamua passed through our solar system, its strange motion and brightness variations sparked intense debate. Some even speculated about artificial origins, before more grounded explanations took hold. And now, history seems to be repeating itself. As more observations came in, astronomers noticed something else. The object's motion was slightly off. Not dramatically changing course. Not steering, but showing small deviations from a perfectly gravitational path. This kind of behavior has been seen before. Radiation from the sun can create tiny forces, especially on lightweight or oddly shaped objects. Over time, these forces can nudge an object just enough to alter its trajectory. It's subtle, but measurable. Still, when multiple small anomalies stack together, they start to feel bigger than they are. And that's where human curiosity takes over. Because when something doesn't fit perfectly, the mind begins to explore possibilities. Could it be an unusually dense object? Could it contain materials we rarely observe? Could it be a fragment from a completely different kind of planetary system? Or is it simply something we don't fully understand yet? That last option is often the most likely, and the most frustrating. Because science doesn't jump to extraordinary conclusions. It moves carefully. Slowly. Reluctantly. Even now, there is no evidence that this object is artificial. No confirmed signals. No verified structured transmissions. No proof of technology. But that doesn't make it uninteresting. In fact, it makes it more important. Because every interstellar object is a messenger. It carries information from a place we cannot reach. A distant star system. A different chemical environment. A completely separate cosmic history. And by studying it, we learn something new about the galaxy we live in. What makes this object fascinating isn't that it breaks physics. It's that it reminds us how much we still don't know. The universe doesn't need to be artificial to be mysterious. It only needs to be vast. And sometimes, a small, silent traveler passing through our solar system is enough to remind us of that. But just when astronomers thought they had a reasonable explanation, something else changed. The object's brightness, previously steady, began to fluctuate. Not dramatically. Not like an explosion or a flare. But enough to be noticed across multiple observations. At first, this didn't seem unusual. Many small bodies in space vary in brightness as they rotate. Different surfaces reflect light differently. That's normal. But this pattern wasn't entirely random. The fluctuations appeared to follow a loose rhythm. Not perfectly repeating. But not chaotic either. And that's where things became difficult to interpret. Because space is full of patterns. Some meaningful. Most not. The human brain is wired to detect structure, even when none exists. So scientists approached the data carefully. They tested multiple possibilities. Rotation. Surface composition. Irregular shape. Dust clouds. Each explanation worked partially. But none explained everything. And that's the uncomfortable space where real discovery happens. Not certainty. Not answers. But tension between what we expect and what we observe. As more data came in, teams began analyzing the object's light in greater detail. Breaking it down into wavelengths. Searching for chemical fingerprints. What they found was inconclusive. There were hints of common elements, carbon-based compounds, possibly silicates. Nothing shocking. Nothing impossible. But there were also gaps. Missing signatures. Unexpected ratios. Not enough to claim something extraordinary. But enough to keep the question open. And in science, an open question is powerful. Because it drives observation. It drives debate. It drives progress. Meanwhile, telescopes around the world continued tracking the object's path. And one thing became clear: it wasn't staying long. Like previous interstellar visitors, it was just passing through. A brief guest in our solar system. That meant time was limited. Every observation mattered. Every measurement counted. Because once it left, it would never return. And that urgency created pressure. Not panic. But intensity. Scientists coordinated across continents. Data was shared in near real time. Observatories adjusted schedules to capture as much information as possible. For a short moment, the entire astronomical community was focused on a single point in space. And yet, despite all that attention, the object refused to fully explain itself. No dramatic outbursts. No clear comet tail. No definitive classification. Just a quiet, persistent mystery. And maybe that's what makes it so compelling. Because not every cosmic discovery arrives with a clear answer. Some arrive as questions. Questions that take years, sometimes decades, to resolve. Oumuamua was one of those questions. And even today, scientists still debate its nature. Now, this new object joins that category. Not as proof of anything extraordinary, but as a reminder of how much remains unknown. Because the truth is, interstellar space is not empty. It's filled with fragments. Debris from distant star systems. Remnants of planetary formation. Objects shaped by environments completely different from our own. And every once in a while, one of those fragments finds its way here. Crossing unimaginable distances. Traveling for millions, perhaps billions, of years. Until, briefly, it becomes visible to us. And in that brief moment, we try to understand it. But understanding takes time. More time than these objects usually allow. So we gather what we can. We analyze. We debate. We refine our models. And slowly, piece by piece, the universe becomes a little less mysterious. But never completely understood. Because just as we begin to explain one anomaly, another appears. Another object. Another signal. Another question. And that cycle never ends. Which leads to a deeper realization. The goal of astronomy isn't to eliminate mystery. It's to explore it. To push against the boundaries of the unknown. To follow the evidence, wherever it leads. Even if the answers aren't immediate. Because sometimes, the most important discoveries aren't the ones that give us answers. They're the ones that change the questions. And this object, whatever it truly is, may be one of those discoveries.